Hi, my name is Eli Stein. I'm a composer, programmer, and educator currently teaching at Oberlin Conservatory in its Technology in Music and Related Arts program. Today I'm going to be talking about ICST Kristall Motion Map, which is a Reaper plugin that I worked with the amazing Johannes Schuett on this past summer as part of a residency that I was having at ICST in Zurich. And today I'm going to talk a bit about how this software works, additionally discuss how to install it, and then go over some projects that I've been working on that just show off some of its features. The impetus for this project was crystal space groups, and in particular, this very basic concept of an infinite lattice of equidistant points that has a kernel that is transformed in a particular offset of XYZ, and then that process is repeated over and over. And this is how crystals are formed. There's a variety of different ways in which they can be transformed and packed in different ways. And this fascinated me in particular as a spatial audio creator to think about how this could be done in the context of spatial audio, or could be sonified or could be heard in some way. So the Kristall Motion Map came from me bringing this to Johannes and saying, I would love some kind of system where you could take a sound and then shift it some amount of an offset of XYZ away, and then repeatedly do that and kind of see what that would sound like in space. And this system, as it stands, does not produce any sound in and of itself, and instead just dictates where sounds are. So it's a motion map in that it is taking particular sounds that you create and then spatializing them in very interesting ways, which I will show you. Before I show you anything though, I will show you how to install this plugin. If you direct in your web browser yourself to ambisonics.ch, this is the lovely web page for the ICST Ambisonics plugins and a variety of other things that Johannes and his team have created. In particular, for Kristall Motion Map, we need to go up to Docs, and then to Plugin Docs, and then on the left goes to the ICST Kristall Motion Map User Guide. This is an amazing resource that Johannes created that goes through all of the features of this software with a lot of great visualizations of what's going on, and is very in-depth, and I will not be going over it in its entirety. Instead, I'll just be showing off how to install the system, and then, as I mentioned before, a couple of projects that I created just to demonstrate how it works. So on this page, if you scroll down to requirements, I will tell you the base requirements that you need to get this system working. The first is Reaper version 6 or 7, which is the latest version. If you go to reaper.fm, you can download Reaper, amazing digital audio workstation. Additionally, you will need the ICST plugins, which are linked under this installation link here. If you follow that, you'll get to another installation process, which I won't go into depth, but you'll need the SWS and S&M extensions for Reaper for this, as well as Repack, which is this awesome package manager for Reaper, which allows you to install scripts, extensions, a variety of other things that you can play around with. And then lastly, you'll need the ICST Ambisonics release, one of the releases. The current release as of making this is 3.2.0, so we can download that and install that for Mac, Windows, or Linux. Okay, so you've installed Reaper. You've got the ICST Ambisonics plugins installed into Reaper. Another requirement that's listed here, more of an optional requirement, is Python 3 with Python OSC, which is required for the live OSC preview bridge. There is a one-liner that you can do on Mac OS or Linux. On Windows, it's a little more tricky, but there is a link to installing Python and Python OSC on Windows here. So my assumption is you have all of these up and running: Reaper, ICST, Ambisonics plugins, Python 3 if you'd like it. We can then go on to the installation of the Kristall Motion Map itself. So if you click this link, the ICST Kristall Motion Map bundle, This will download a zip file. I have a bunch of these. Maybe I'll delete those. I can then extract this. This is double click on Mac, or here I can just do extract all on Windows. And it gives us the ICST Kristall Motion Map bundle in a folder. Now, you can actually put this anywhere if you'd like. But what I would recommend and what Johannes recommends is putting this into your Reaper scripts folder. If you've never worked with Reaper, you can open up Reaper and go up to Options, Show Reaper Resource Path and Explorer Finder. And this will show you the Reaper folder. This will be a little different on Mac, of course, or Linux. But ultimately, what we're looking for is this scripts folder here. And you'll want to take the bundle for the Kristall Motion Map that you downloaded and put that entire folder into scripts within Reaper. And again, this could be anywhere, but it's just nice to have it here because it is a Reaper script and it makes sense for it to be in this space. Okay, so you've placed that bundle into the location that you want it to live. Next, we'll open up Reaper, then go up to Actions, Show Action List, then go to New Action, Load Rescript, and then point it to within that folder, in the scripts folder, the Lua source file, which is JS ICST Kristall Motion Map. So I'll open that up. And this in and of itself is just loading the rescript. So it has it now in this actions list. Then I can double click on that. And lo and behold, we have the Kristall Motion Map installed. Okay, I've closed up the Kristall Motion Map because we actually want to work backwards from from the ICST ambisonics plugins into the Kristall Motion Map. And that'll make sense once I show this off. The ICST ambisonics plugins having been installed, you should be able to go over to this left side of your screen in Reaper 7, right-click, insert track from template, go down to ICST ambient plugins, the ICST ambient coder multi-8 source, and we can create that. It'll show a little pop-up. We don't need to worry about that. Just hit OK. And now we've created an ambient coder, which allows us to take 8 source sounds and project them into 3D space. I won't talk in depth in this video about ambisonics. There are a variety of different videos available, including some on the ambisonics.ch ICST website that talk about excellently about ambisonics and introduce it. But what I will show you is just how to connect up this plugin to the Kristall Motion Map so that the Kristall Motion Map can affect the spatialization and localization of these different sources. So we have this set up. We will go to Actions, Show Action List, and then go to what we just installed, the ICST Kristall Motion Map. Double click that and make it a little bit bigger so it's easier to see. And what I will do next is connect up the Kristall Motion Map, in particular these different sources that I'll talk about over here on the left, which correspond to different sounds in space. I will connect this up to the ambient coder over here. And this is done through OSC, which stands for Open Sound Protocol. You can see kind of at the lower left side of this plugin, the Kristall Motion Map plugin, it has an OSC section. And you'll notice it has this red circle, which means it's not connected. The other parameters here include the host or kind of location where you're doing the OSC from, which is 127.0.0.1 for this computer or local host. Then we have the port, which is 9001, which is very important, and then a connect button. And I will click the connect button, and it'll take a second to set up some stuff going on in the back end. Okay, now we're connected, and next we need to go into the ambient coder plugin, hit this gear at the top left here, and then I will go to OSC in, receive OSC, and then, as I said, importantly, we need to set this not to 50,001, but to 9001. And now instantly you will see that these sources have changed. to be in a configuration that is what we see on the left in the Kristall Motion Map. And just to show this off a little bit, there's a section down here at the bottom called Rotate. If I rotate our cube over here, you'll see that it modifies the spatialization of those sources and has a direct one-to-one relationship between the Kristall Motion Map and the ambient encoder, which is producing the sound. This is the depth of the system and kind of the depth of what I'm going to show for installing it and getting it functioning. Next, I'm going to show off some projects that kind of demonstrate the different functionalities of the Kristall Motion Map. Okay, so this is a demo project that I've set up. Everything that I'll play will be needing to be listened to in binaural audio, as I mentioned at the beginning of the video. This requires headphones, and I'm utilizing this binaural decoder as my output of all this encoded spatial information. So use headphones, or else the spatial trajectories and kind of the imaging of everything will not be correct. Let us break down the different elements of the Kristall Motion Map plugin. And I'll do that by going to the lovely page that Johannes has set up, in particular, this third section, the interface at a glance. The interface can be split up into 4 areas. We have at the, let me zoom this in a little so we can see it better. We have at the top left, our instances, and these are just different positions in space to localize. There's 8 of them over here. You can change the name of them. I'll show how to do that. But ultimately, this is just our set of different points or sounds that we want to move around the space. Next, we have this visualization, what's called the lattice preview, which is over here at the top right. And this is a visualization of, in this isometric space, or kind of shifted cube space, where each point exists in our spatial configuration. You also have the set of parameters for each of these instances, which gets back to the different ways in which they can be moved around, inspired by that initial crystal kernel idea of being shifted by an offset, and much, much more that Johannes added in. So that's here in kind of the middle right section. And then at the bottom, we have what you could call the status bar, or kind of the global effects that are being applied to the Kristall Motion Map. Here's a nice visualization of it. So top left, instances. Top right, we have this preview or visualization of what's going on in 3D space. Then below that, we have parameters for each of the instances that we have over on the left. And then at the bottom, we have our global manipulations or parameters. If we go down, I'll talk a bit about the instance list now in this real demo project that I have here. So I have 8 instances over here on the left. They correspond to the 8 tracks that I have in my project. So if I just, for example, play these first 3 synthesizers, these correspond to each of these instances within my plugin. And they are being thrown around. We can actually pause this so that we can grab them individually. So there's my Kristall 1. You can move this around if you'd like. You can also shift it in the Z space, meaning up or down, by holding down Shift as you grab it. So you can individually modify each instance. Additionally, if we get that playing again, you'll see that the instances can move, they can be static, they can do a wide variety of different things that are dictated by all of the parameters here. These include, as I mentioned before, the name, so we could call this whatever we want. I'll just call it Kristall 1 again. We have the position and offset. Offset is each step that's being played through how much it's moving in each of the X, Y, and Z dimensions. Then we have timing below that, which corresponds to the speed at which this is happening. So if we just look at that crystal one, again, if I change this to 16, it'll go twice as fast. So you can see that it's moving a bit quicker now. If I go to 2, it'll be much slower. I'll take it back to that original 8. Below that, we have rotation, which is rotating the sound around its initial starting point. Scale, which is going to be related to the kind of overall size of the different instances with respect to one another. And then bounds, which is really important. Bounds relate to what happens when the sound, as it's being offset or moving, what happens to it when it goes out of bounds or out of this kind of unit circle that we have here. If I turn this off, you'll see that it actually goes into outer space because it just is way offset apart from that unit circle that we typically work with in the context of ambisonics or spatialization. And you can see that there's different ways to bound it. I can clamp it so it'll just stay close to whatever edge it's past, or I can wrap it so it'll move around kind of in a torus. If you get to the edge, it'll wrap back to the other side. Or I can do mirroring, which is kind of my preferred one, where it'll just oscillate as it gets past this unit circle. You can also quantize space and time, which is pretty fascinating to think about. Space quantization is, in a way, pixelating the 3D space that you're in, so that if you are, let's say, at 0.33 and you had quantization at 0.1, it would snap to 0.3, for example. So it would not be able to be in between this grid that's established here, I guess, as 0.25 by default. Then you have smoothing. I can turn that off and you'll see that it's much more jerky. If I take smoothing and make it longer, so for example, a second, it'll be quite a smooth movement around. There it is, bigger. And then last but not least is interaction. And that's a very, very fascinating thing that Johannes did, where the different elements or these instances, as they get closer to one another, will affect their offset and their rate individually. I won't go into depth with that. It's a lot of fun to play around with. And you can ultimately get these kind of swarms of different instances interacting in different ways. So those are all of the different parameters of the instances. Additionally, if we go down to the bottom of this, we can see these global manipulations that we can do. We have speed, which is a global multiplier of how fast things are going. So if I do that at 0.5, things will move twice as slow. And this actually affects everything, including like rotation. So here I'm rotating a little bit, and I'll talk about that in a second. But if I make this 2, you'll see that it rotates faster. I'll go back to the original 1. If you right click on any parameter, it will reset it, which is a really nice functionality. Then I can turn on and off BPM. You'll notice that it stops functioning there for some of the different elements that are not being offset in a particular way. BPM requires that the transport is playing in your DAW, in this case Reaper, as it's going in order to function. And I haven't set this up for BPM, so I'll turn that off. Play will allow you to start things up or pause them here. Stop will also just stop the motion generally. And then you can sync everything, which is basically reset it to its original start point so that you can have deterministic movement, particularly with BPM mode. Below that, you have offset and then move. Offset, I can demonstrate while it's playing. So that's far right, far left. Then I can move it back, so that's behind me, or forward. And then I can modify Z, so that's low, and then up high. And in the context of binaural, this is a little less apparent than when you're working in a half dome or another multi-channel space, for example. Okay, you also have this move parameter, which is going to not only offset things, but actually move them in space every frame or kind of every moment that you're running this simulation. I have some of them unbounded, so they will just kind of float away as I move them. So I'd need to bound those by turning on the bound parameter. If I wanted to do that, I would select those over here, and then I can adjust the parameters within the parameter space here. But for now, that's the move parameter. It can be really cool to do a global move of everything. Then we get to rotate, which will rotate the entire map and those different directions, pitch, roll, and yaw. We have a global scale, which will modify the scale of everything, which can be really cool to play around with. And then we have spin, which like move is going to apply rotation kind of every time step. So we can get it doing these lovely patterns of just kind of rotating in space. Okay, I'll reset that with right click. And then last but not least, one of the cooler things that Johannes added in was to assign whichever instances are selected, or arrange whatever instances are selected, as it's called here, into different shapes. And this is a little easier to show off when you have more points. So I'm actually going to change over to another preset here. This is the preset system. If I've got this set up in a particular way that I'd like, I can name this, for example, my test preset, and then I hit save, and it will save that into this menu of presets that I can load up. But I want to demonstrate the arrange functionality, so I'm going to make a 64 instance preset. I will grab those, and then if I hit arrange, I can arrange them into a circle. I can arrange them into a helix, which is really pretty cool here. I can arrange them into a sphere, a line, which also produces some really interesting spatial effects, a grid, or just randomize their locations there. And again, to do this, I went over to my instances, hit Control A or Command A to select all of them, and then I can just hit that to get the different configurations. Alternatively, you have at the bottom of the screen different presets that Johannes set up as kind of base presets here. And they include a variety of different crystal shapes, along with a kind of random swarm, which is extra cool too. Lastly, going back over to instances, I can remove instances with the remove button over here. I can add them, which will set up kind of a default instance that then I can modify the offset of, various things like that. And I can duplicate. So if I wanted a bunch of this crystal, or sorry, not crystal, this instance, I can duplicate that and get a wide variety of those created. Each of which I could modify or do different things to create a different setup here. Last thing that I'll show off with the parameters is something that was added in very recently, which is taking actual crystals and putting them into the system. So if you click on the COD button there, it will take you to the crystallography open database. And each of these different lines here corresponds to a particular crystal formation. For example, I'll just click on the first one here, 1100118. If you click on that, we can actually see a little visualization of it, which is pretty cool. You can zoom in and see the different different elements of the crystal there, the different atoms, I believe. I can then hit this CIF link. It'll download a CIF file, which includes all the information that was visualized there about the crystal. And then if I go back to the Kristall Motion Map and then hit the CIF button, go to my downloads and then load that in, it will take that entire crystal, its formation up to 64 instances, which is the max number of instances that this plugin can have, and then pull that in, coloring it, which I think is such a beautiful thing. And I'll go to another project that shows this off with a crystal. Okay, this project includes that same crystal that we were looking at, 1100118 from the CIF, and taking the first 8 of the different elements of it, and then having them offset by a particular amount. And you end up with this lovely pattern of spatialization with which I have these different simulations of crystals being run through. And I think it sounds really neat and kind of ties all these things together of crystallography being abstracted into this spatial audio context, and was the real goal of this Kristall Motion Map initially. So I'm super happy that it ultimately came to being able to present these spatial presentations of crystals in sound. Okay, one last thing before I go is, now that we have this system set up, the Kristall Motion Map is modifying the ambient encoder to change spatialization. This is all well and good, but what if you wanted to take this and turn it into automation? And the way that you can do this is fairly simple. If you go to the track that has our ambient encoder on it, we can change this to latch mode instead of trim mode. And you'll see as soon as I do that, all of the different parameters of the ambient encoder that the Kristall Motion Map is changing over time. In particular, for each of the 8 sources here, we have the X, Y, and Z being modified. All of those get revealed, and you can see that they're being changed. So in a way, the Kristall Motion Map is an automator of the ambient encoder, and we can certainly take that automation and record it out. So what I'll do is I'll play this back, just hit spacebar, and then once I'm done, I can just go back to trim mode. So I'll jump back to trim. And then what I can actually do now is close up the Kristall Motion Map, because we've recorded all of the automations that it's done. And then if I play this back, we'll get the lovely spatializations that the Kristall Motion Map created onto our automation, which we can then export out to our heart's content. So I think that's where I'll leave it. Thanks for your time. I hope you have fun using the Kristall Motion Map.